Hello everyone. I hope I'm audible and welcome back to another session of Introduction to Machine Learning. So, as discussed in previous class, you have suggested that I should take a class on ensemble methods. So, today I'll be taking classes on ensemble methods in Python and I'll just share my screen, and before that, I'll share the collab link. So, yeah, I have shared the collab link in the message and please let me know if my screen is visible. My screen is visible, right?
Yes, ma'am.
Yes.
Okay, great. So beginning with ensemble methods. Ensemble term itself means collection of thing. That can be anything, right? Ensemble means just a collection of thing. In Python, ensemble method means when we take different models or multiple models at a time. Why that is neat? Because till now, whatever classes I have taken, I have deal with so many machine learning algorithms like linear, logistic regression, linear regression, SVM, KNN, etc., etc., etc. Right? Every model have their own pros and cons, but that is what human need is. It never satisfied, right? So what we need is we want to ensemble, we want to take all the benefits of all the different algorithms into one place. And how we can do is that is where ensemble method comes. Okay, so I just a short question, do you guys have covered this ensemble learning in your theoretical part, and if yes, what are the extent that you have deal with? Please let me know.
Yes,
Guys,
ma'am. It
yeah,
was covered in the theory.
sorry, what?
Uh, it was covered in the theory lectures.
Yeah.
So we learned about bagging and other methods.
Add a
Add a
boost.
boost grid.
Yeah, okay, great, great, great. Okay, then today I'll be dealing with different models of ensemble, and I have taken three most popular method for this. One is bagging, which you know, like one is boosting and one is voting. I don't know if you have covered with voting or not, but this is one important method that is recently being used a lot. So coming to that, like I'll initially take the little bit of theoretical part so that that will be easy for both of us to have the hands-on session for the Python thing. Okay. So talking about bagging, it's more of it. First thing it is that bagging is always done on the same type of models. What I meant is you cannot do bagging for regression as well as classification. Okay, because for regression the problems and the algorithms is different. For classification, your results and your problem statement and everything is different. Okay, so keep that in mind. Yes, for sure, SVM and KNN, or there are so many different methods which can be used both for regression and classification, but they cannot be used both at a time. Okay, so that is what bagging does. It takes multiple models, obviously, but of the same type, and it takes in subsamples method. Okay, we will see how it is done. Second is our boosting. Boosting again it does for multiple models again on the same time, but what it does is it learns to fix the prediction errors. What I it meant is before we like if you're using one model, whatever the error is coming, the next model is trying to learn from it, and then the things go on, the chain goes on. Okay, so this is how boosting works. While voting, as it terms it the name tells, this is where different types of model if you're working on can be done using voting. But as the there is a term called voting, right? So what we do is using different models itself and with different types, we do a voting in the terms of statistics. That statistics can be either average, mean, median, mode, whatever different kind of statistic we take, and then we do the predictions. So it's more of like okay, if this is a more number of this, then this has a good average or giving good mean or lesser error. So go for this model, otherwise go for that model. Something like this. Okay. What exactly these three models are, we'll see with the hands-on training. With the bagging itself, I have covered this section in three parts. One is decision tree, one is random forest, and one is extra trees. Okay. So trees, decision trees, what it does is, if you have a data, it will try to split it. Okay. There are two things done in decision tree. One is splitting, one is pruning. Pruning means, okay, if we have a plant, and if that unwanted leaves are coming off, what we do is we will cut it off, right? So that is what means pruning. Pruning means, so what we do is, if we have a data and there are so many subparts of it which will be coming out of that decision tree, which is more of like splitting the data, so we keep it cutting as well all the data which are not required. That is what decision trees. Okay. So okay, let's go with the decision tree, like the hands-on training itself we will take with. So I have done the back decision tree for classification. Okay. So, like, till now whatever I was doing was, I was explaining one algorithm, I was doing it for certain different data set, right? Over here I'll be sticking up to one particular data set. I'll be sticking up to similar kind of models or patterns, so that it will be easy for you to compare, to see how different ensemble methods are giving result on the basis of different models with the same data set, and with the same, every parameters are kept same. Okay. Only the models, the ensemble methods will be changed, so that you can do the comparison. Okay. Okay. So starting with back decision tree for classification. So I have, yes, of course we have different libraries which needed to be imported. And for the EC, again, there are two methods. Always and always, there is one raw method which you can write all the models from your beginning. You have to code it, which I prefer. I don't prefer it. Why? Because obviously it is very good for learning part. If you are at a learning stage, I would recommend you to do that. But if you are at a later stage, if you want to know what your classifier is doing, or if you want to just get the result out of it from your data set, then you don't need to go for the basic, because it consume a lot of time. Okay. So what I will suggest is, obviously the first class I dealt with was scikit-learn. So there's something called sklearn. So from sklearn we have all the classifiers. I again recommend you go to sklearn before doing any Python programming. Whatever classification or regression or any kind of model you're working on, or a neural network or a deep learning model, I would recommend you to go to sklearn and see if that model is present or not. Okay. So over here itself, I wanted to go for bagging, and in bagging, decision tree. There are two things, right? So firstly I did was, I have imported model selection from sklearn. So model selection is a group of libraries, or a group of you can say a package, which have all the models, all the different models in sklearn. So first I'm calling that. Second, I need to call the ensemble method, right? So I'm calling from sklearn.ensemble import bagging classify, because I'm working with bagging, right? Third one is from sklearn.tree. Why? Because I'm working with decision tree classifier. So you can see the pattern, right? Firstly, there was just sklearn. I was calling the model selection. That was a package covering all the classifiers. Second was, since I'm working with ensemble method, I'm calling dot ensemble with bagging classifier. Third was, since I'm working with decision tree, I'm calling dot tree and importing my decision tree classifier. Okay. So this is the part where I used to call my libraries and packages. Okay, done with that. Next thing is about data. So till now, there are so many ways I have shown you the how you can import your data. One was either uploading on your Google Drive and directly copying that path from your Google Drive. Second was directly copying your data into your, this collab. If you're working on collab, directly copying your data into the collab. Third one was, if you have your data in your local device, means if it is stored in your system. So even then you can upload it on your this drive, or not even drive, if you want, if you're working in Google Colab, so you can upload it on cloud, and then you can just call it. Now the fourth method where I want to show you is how you don't need to download or store or import any kind of data. You can just directly give the direction, the link of the data where the data is present. Okay, and you have to, that URL we say as URL, right? So for any like whatever data which is present online, you can directly call them using the function URL. Okay, so this is one method I wanted to show you, and this is here I'm showing you that. So with URL, I'm just directly calling. See, this is the link itself. If I will just copy paste this link, you will go to the data where the data is present. Okay, so I'm directly calling from that. I don't need to store it anywhere. I don't need to consume my memory. Okay, so the data set I'm using is a diabetes data set, a data set which have a number of patients and the different parameters, uh, which tells if a person is a diabetic or not diabetic. Okay, so for any data set to work on, you need to know what kind of data or what kind of headers or information that data set is providing. Okay, so we can see, I before working on this data set, I went to that data set, I looked at what all the parameters, what are the information that data set is providing me, and these were the classes that was there in that data set. Okay, so I took that data sets names, plus whatever the data sets names were given, and then I'm creating my data frame. Okay, I'm creating my data frame. I'm calling my pandas. See, in imported pandas, right? So that is what it does. It creates a data frame. So I'm calling my pandas and I'm asking it to read that CSV because it's a CSV file. And what all the parameters it needs to know? First is URL, that is telling about the whereabout of data, where the data is present. And second thing is names. So what are the things or what are the content present in that data? Okay. Next thing, I need to convert that data frame into array. What does array means? In simple terms, you can tell it as matrices. Okay, so my data frame is mostly about how you prepare in Excel sheet with all the details, names, all the values. I don't want in that because I cannot work on that because my system, my algorithm doesn't know how to work on that. Ultimately, whatever algorithm we are proposing or doing is, it's a calculation, right? It's a mathematical computation, so it needed to be in the form of numbers. So that is why there's a need of converting it into array is nothing but in matrices form. Okay, so I've converted my data frame, like the data frame, the values it is having, into array. Now I have to give what is my x, that is input, and what is my y, that is my prediction. So x is equals to array, and this means what are the columns I'm giving. So I'm telling it from 0 to 8. So this colon means you have to take all the values starting from 0 to 8. Similarly, y, for y, it is not telling take all the values from 0 to 8. It is just telling take the 8, the final value. And that is how we do, right? We have seen all the predictions, what we do for all the algorithm which we do. We have 10 columns. So 9 columns we give it as input because those are the factors, or even not necessarily 9, whatever the relevance is, or at least 4 or 5 out of them, and one column which has to be predicted. So over here, what prediction will be? A person is a diabetic or not diabetic. So that is that information is stored in my 8. So 8 of the column. So that is what array is telling. Okay. Now my thing is I have to give the models. So there's something called k-fold. Okay, so I'm giving the k-fold model. K-fold is a kind of a validation method. So how validation is different from testing and training? Okay, so training is something which we train our model. Okay, testing is something which we test our model, that if my model is accurate or not, which is done at the final stage, right? While validation is something which we do while doing the training. Now suppose you have thousands of data. Okay, and what if, and not even thousand is a small number, I would rather suggest lakhs of data. Okay, And think about it, if you are training like recursively of that data, like the whole 1 lakh of data, and after it took 2 or 3 days of model to learn or train that data, and after that when you test it, you identify, okay, there was some fault or there was some error, and your training has been wrong or your model trained it wrong, right? So when you test it, then only you will get to know. But it's a loss of time, it's loss of memory, energy, computation power, so many things, right? Okay, what happened? Something. Okay. If you have any question, please ask me in between, okay? Okay. So, where I was? Yeah. So you cannot do that. Okay, right? So that is very tedious. So what we do is we do a validation process. So what validation does is, in a set of like, if I'll give key after every 1,000 training set, do a validation. So validation, what it does is, from the given data set itself, from the training data itself, it will just predict if my result is coming correct or not, if my model is training correctly or not. Okay, so this is what validation is. So k-fold is a one type of validation, and I am giving it n split is equals to 10, which what I am telling is, split the data into 10 parts, tenth of every part, and then do the validation. Okay. Now I'm giving the decision tree classifier. Okay, what is happening? Okay, students are joining. Okay. So, please let me know if you have any network issue in between or if you have any doubt. Okay. Okay. So now I'm giving my decision tree classifiers into the cart, which is a variable. I'm giving the number of trees, which is 100. This is obviously a variable. You can change it whatever you feel. And again, like knn, we don't have exact value of k. Similarly, in decision tree, the number of trees is not defined. This is more of hit and trial method. Okay. Now I am doing my model. For the model, I'm giving my baggy classifiers. So base estimator, what is the base estimator? Decision tree. Okay. N estimator, what is the n estimator? What this is the number of trees. Was my number of trees? 100. And random states, like I don't want to keep any random state. I don't want to shuffle my model, shuffle my data or something. Okay. So now I'm doing the result, going for the results. It's a, I'm asking it to select that model, which is my model selection over here, right? I have imported its model selection, right? And I'm doing this cross validation, and with whom we are doing the cross validation? On x and y. And I'm asking it to print the result. And what result? The mean result. Always the mean result. Why? Because I'll be having hundreds of results, right? So, like, what results will you take? So we I want the mean of result, average of result. So the result, the score was coming around 76%. We don't know if it is good or not, but this is a very small python programming which I wanted to show you using back decision tree. Okay, so this is one thing. uh I hope I'm clear, like, for the ensemble methods. Okay, so this is for the decision tree. For the backing itself, there's another model or method, which is random forest. So random forest is basically an extension of decision tree. So what it does is, like in decision tree, we splits our data, and whichever is not required, we cut it off, we prune it off, right? Random forest, what it does, it basically take all the different datas, it kind of create a network, and it tries to find the correlation between them, and on the basis of them, it decide which is the best split. It not directly do the splitting, it decide which is the best split, and then do the uh, take the random subset of that particular split. Okay, this is the difference between random forest and my decision tree. So again, the same thing I told you for all the ensemble method algorithms and the models. You will see similar kind of like Python programming, except for the models. And the main reason was to see the, like, accuracy thing. Because if we'll not use the same data and same parameter, how we are going to compare, right? So again, the same thing. I called the skill on model selection. I did dot ensemble. I've called the random forest classifier. Okay, the URL, same data, the names. I'm calling the data frames. Okay, I'm calling the array data frame dot value. Again, same parameters. Everything I've given the same. X and Y value are the same. This seed is not important. This is something which is really not important. You can ignore it. Okay. So number of trees, again I have given 100. Maximum features. Why maximum features? Yeah, why maximum features is needed in random forest? Because like in decision tree, we needed number of trees which is needed over here itself. Maximum feature is till what extent you need to keep on splitting the data. So this is what maximum feature is. Over here it is taking three maximum features. Okay, at least there should be three maximum features. Again I have taken k-fold, and again I have kept the same thing, and split is equals to 10. Model random forest classifier. N estimator is again number of trees. Maximum features, which has been defined 3. This is one parameter which is needed for random forest classifier. Take it as in that way. Okay, maximum features, nothing to worry about that. And again I'm doing the cross validation, the same process, and again I'm calculating the mean. So over here I'm getting 0.75 or 75% accuracy. For decision tree I'm getting 76%. So comparatively decision tree is giving better result, right? So this is just depends on the what kind of data you are taking, what parameter you are taking. It may be like if you have taken some other data and some other kind of parameter, your random forest has given better results. So nothing like that, and there's not a much difference, right? But one thing is sure, these are all bagging methods, sorry, bagging methods, right? Now extra tree. Extra tree is mostly again it's a modification of bagging, where random trees are constructed from sample of training data set, which means my random trees, it was splitting my data into different sections, right? Extra tree is something which, when my data set is becoming saturated, or where my samples are not getting enough result, then this is mostly used. Okay, so extra tree classification, this is something, again extra tree is extra itself, which I have considered for this program. I just wanted to know, like, you should be familiar with this word if in case if you hear in the future. Okay, so again there's, again in the ensemble there's extra tree classifier model, and other things are exactly same, like everything is same. Again you can ignore the seed is not required. Number of trees 100. Over here I have taken maximum feature 7. Why? Because I told you extra tree and random trees or random forest, there's just very thin line difference. The number of trees it's being splitting, the end part. Okay, so random forest is always very minimum, it's always 2, 3, 4. But extra trees, that is why it is named as extra, because it always may take the features, like more number of features. So then the maximum feature is 7. So that is the only difference. Okay, so you have more split, or more, you can say, the features which can be described. That's it. Again the same thing, I'm calling the model extra tree classifiers, and the models, I'm calculating the results with the cross validation score and the mean of that. So let's see one thing. Can you see, almost it's the same, right? The accuracy for random forest and the extra tree, which the features are different. Over here I've taken 7, over there I've taken 3, right? Other than that, it's everything is same except for the classifiers. It's extra tree classifier, it was a random forest. But can you see the accuracy itself? 75.64 or 75.6, it doesn't matter, it's one of the same thing. That 1.01 accuracy doesn't matter in the model. You cannot consider a model better until unless it's more than 1 or 2 percentage of accuracy, or I should say more than 5 percentage of accuracy, to be honest. Okay, so this is similar, this is giving similar result. Okay, so it's nothing like your extra tree or your decision tree for this data set, for this particular parameters. You can interpret at least this thing. So from all the bagging tree models, you can see for this data set and this parameters which we have considered, my random forest is giving better result. Okay, because it was 76% comparatively, right? Now my bagging is done. Bagging, we have seen how my different models I use, how we can take the different models, different classifiers, features, etc. Okay, now the next part is boosting. So what does boosting? Over here I have written a line that boosting ensembles algorithm creates a sequence of models that attempt to correct the mistakes of model before them in the sequence. Which means boosting basically do is it tries to like when I taught you in my when I was teaching you neural network, there was something called backpropagation, right? So what it does is it used to learn the weights, and then used to update it. Boosting is similar kind of thing in a different way. It tries to, like, correct their mistakes for the next model when the previous model have done some mistake, okay, or some error. It tries to rebuild it. Okay, so for over here I have taken two types of machine learning algorithms for boosting algorithm. One is AdaBoost and one is stochastic gradient boosting. Okay, before getting into AdaBoost, stochastic gradient, can anyone tell me? I have personally taken care of gradient term when I was teaching neural network. Can someone tell what gradient means was at that time?
Ma'am, gradient is to calculate the partial differential. I mean, uh, back we learned
Okay.
during back propagation. So
Hmm.
yeah.
Mathematically, you are correct. Mathematically, you are correct. Correct. If I have to tell it in a very simple way, gradient, it is more of like, you can say steps. So you take different steps, either downward or upward, to reach a particular point. And in our neural network, what was that particular point? To have a minimum loss zero. It can never be zero, loss can never be zero, or error can never be zero, but we can minimize it, right? So to go to that zero level, to that convergence level, we term it as convergence, that our model has been converged, we use gradient. So that is what gradient term is. It's more of a step, either take a smaller one, like a downward one, or the upward one. Okay. Okay, so getting back to AdaBoost. So AdaBoost is again a boosting one, but how does it work is it takes the weight instances, that how, and then try to classify my algorithm based on its weight instances, that if my algorithm is easy or difficult. Okay. Okay, so let's go to the modeling part. Again the same thing, again I'll tell you, I have taken again the same parameters so that you can do the comparison. The main purpose of me taking all the parameters and all the data and everything similar, so that you can compare all the models with each other. Okay, and again I this seed is not necessary. See over here I have written random state is equals to seed. So seed is mostly a thing where you have to tell, okay, after this point, this after this particular point you have to randomize the model, or after this particular point you have to keep the model static. You can always keep it none, there's no issue, it will work perfectly fine. Okay, and you can just ignore it if you don't want it. It's not much of a use, at least for this data set or this work. Okay. Okay, so for AdaBoost, again I have called the AdaBoost classifiers. I have taken my data set and the different names, created the data frame, created the array. I've taken X and Y, again the same parameters, everything. The number of trees. Till now, the number of trees which we were considering was 100. Okay. Why? Because for bagging, we need more number of datas, or for like decision tree, random forest, etc. We need more number of datas to do the division, to do the splitting, pruning, etc. 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 For Adabos classification, this is very much precise. We, if we are taking more number of data, it's very difficult to update the uh, like what my like boosting was. It is considering the error which has already been happened, not in the, like, it is actually correcting its mistake in a simple term, right? So think about it, if you have hundreds of data, it will be very difficult, it will consume a lot of not hundred of data, I'm so sorry, the number of trees, the number of splitting. So we reduce the number of trees over here. The number of trees is 30. Okay, we have again taken the k fold, we have again taken the model. I have n number of trees, random state I've taken none, I don't care. Results, I have taken the models, different models, and I've calculating the mean. So you can see my accuracy is coming around 76%. This is for AdaBoost classifier. Okay, next is my stochastic gradient. Okay, so stochastic gradient, this is the, like, these two methods which I have taken, AdaBoost and stochastic gradient, you'll be hearing throughout your theoretical class if you have gone through it, or throughout your machine learning, advanced machine learning, deep learning. These two terms are used a lot. Okay, so boosting is something which is actually used in machine learning a lot, because it's an updated version of, you know your models. Like if you're using different multiple models, so if one model is making some mistake, it doesn't matter that it is not necessarily that second model will do the same, it will try to improve it. How? By doing, by these algorithms. So that is why these models are important. Okay, okay, so for stochastic gradient, I'm calling the gradient boosting classifier. These are the names. You will get it if you will just search in sklearner what are, if I want to do stochastic gradient boosting, what is the name of it. For the classification, it will give gradient boosting classifier. For regression, it may have some other term, right? So okay, gradient boosting classifier, I again taking I'm taking a data set by URL, different names, data frames, array x and y. Again I'm setting the same thing, the seed is not required, it's not at all required. Over here I've taken number of trees 100. So your question would be, why the number of trees was 30 in the previous one and number of trees is 100 in this one? So the very basic thing is, when we talk about ADA boosting is a technique which, like, it doesn't need so many number of, splitting of datas when it is training a data. Why? Because it is trying to recover itself, trying to correct its mistake from one model to another model. So if we have more number of trees, it will take more number of, like, it will consume more number of time. but for stochastic gradient, what I told you is it's kind of a step. So we need to take different step to reach a particular point. So in this, we need more number of training data, or we need more number of trees to be splitted and to be proved. If we not do that, then what will be the issue? We Either we will go to overfitting situation, or either we'll go to underfitting situation. Either of the two, because we will miss. Think about it. If you want to, like, again, I have given the same example. If you want to go from one step to another step, and you don't know if you're skipping once, like, if you take two step at a time, what if the one step you miss, that is the point where the convergence is happening? So you cannot take that risk, right? So that is why we have to take number of trees as 100. Okay, we have to take more number of data, we have to take more number of splits. That is, we can do the classification method. Okay, so other things are similar. I'm taking the gradient boosting classifiers. I'm doing the cross validation. I'm printing the results in the mean process, and you can see the results for stochastic gradient and my this AdaBoost is somewhat similar. It is 76.04 and it is by 76.5. So somewhat similar. Like, this is performing better, maybe because of number of trees. That can be one reason, but not necessarily. So this is more of like, you cannot judge the model or the network just based on this. This is one very basic example right now I'm taking, and I'm keeping the data set and all the parameters exactly same. But that is not always the case. It's not the ideal case. You have to change your and there is a term called hyper parameter optimization, which plays a very crucial role when we deal with machine learning algorithms. Okay, so optimization is one process where you need to, do a trade off. What trade off basically means is there are two things. Either you can increase your accuracy, or either you can increase your computation power. So what we do is we take a middle road. We don't want to increase our computation also, and we don't want to sacrifice our accuracy of the model as well. So what we take do is somewhat we deal with the parameters which has been considered as somewhat in the middle ground and similar with the accuracy. Okay, if my accuracy is coming around 90% with this parameters, okay, fine, that accuracy could have come like 95% as well, which is a huge difference. But for that I need to change my parameters, and for that I need to give more computation, which my laptop cannot like, or which my system or my model cannot sustain. So we take a middle ground. Similarly like this, there are situations where have to take a middle ground. Okay, so yeah, my stochastic gradient is done. Now voting.
Ma'am, sorry to interrupt you. I have two questions
Yeah, please, please.
regarding this. So, ma'am, for the ADA boost, we know that the loss function is exponential, right?
Uh-huh.
So, for the gradient boosting, sir said in the lectures that we can select any arbitrary loss function.
Mm-hmm.
So, what is the loss function chosen by the SK learned kit? Can you elaborate?
That I have to check. Mostly for gradient boosting classifier, the loss function mostly are, there are two types of loss function. One is for classification, one is for my regression. So for regression we mostly take MSC. Mostly, not necessarily. MSC is mean square error for regression. And for classification we mostly take cross entropy, if you have heard this name, or softmax, either of the two.
Okay.
Okay, so we don't know, we have to check on it. What I meant is, right now I'm just using this sklearn, and I'm using this already created this gradient boosting classifier. I'm just calling it. I wanted you to see how you can deal with different kinds of boosting and bagging classifiers, and what kind of results they are doing, keeping the same parameters. If I can change the parameters into this, like different parameters or other different, optimization, I can assure you all the models which we have dealt till now would give either good, like a positive result, a higher accuracy, or a lower accuracy, but it will change definitely. But to do the comparison purpose, can you see like all the accuracies are almost similar, like 76, like point some decimal differences are there, that's it, but not much difference. Why? Because my data set and my parameters are same, and all these models are somewhat connected to each other. They perform one thing or another thing, they perform the same rules, same set of rules. So that is why they are giving similar result. Okay.
Okay, ma'am. And ma'am, another
Yeah.
question I had
Yeah.
for like boosting, we do a forward stage wise kind of thing.
Uh-huh.
So during the stage wise, we used to add another features. So here we add another, classifiers.
Mm-hmm.
So can we do it like, let's say a particular model, let's say decision tree,
Mm-hmm.
create some error, and that
Mm-hmm.
is being corrected by, let's say, a neural network. So can we
Uh-huh.
do such kind of things
Yes,
with
of
boosting?
course. And that has been done. You should look for it. Actually, that has been done. There are so many different models that has been created from this thing what you are telling. And this is how models are created. Like what you're telling is a very good example. And there are things that has been done with this. So you should actually check on this. Okay?
Okay, ma'am. Thank you.
Yeah. Okay. So voting in symbol is most of like you have to do the voting. Okay, so before starting the class, I told you that bagging, boosting, right? So in boosting, I told you ADA boost and like my stochastic gradient. And the third one, I apart from bagging, boosting, I told you one was voting ensemble, right? So both bagging and boosting were performing on the same type of model, but and you can see in this there is this one model which is being classified, right? In voting ensemble there are different kinds of models that will come. There are sub models. Take it as an example of voting is means that there are different categories. You have to choose which is better, and criteria for that is statistics. So we look on the different mean, average, median, different kinds of statistic methods, and then we decide which is the better one. Okay, so for remember this, we will go down, we'll see like we have different kinds of sub models for voting, and that was not in the case of bagging and boosting. So for voting, you can see a different, little bit of different in the Python programming, but again, the data set and the parameters should be same, and I have kept the same to do the comparison. So, okay, I imported the pandas, I have imported the model selection, but what I told you is voting have different kinds of model. See the different kind of model. Dot linear model I have taken, which is logistic regression, first model. Dot tree I have taken, that is decision tree classifier, second model. And dot svm I have taken, that is svc, that is third model. Can you see I have taken three different model. One is a linear, one is a tree, and one is a svm. Okay, and now I'm calling the ensemble, that is voting classifier. See, now we have to see how this works. Okay, for different models, this is something interesting. Okay, so I have the, again, the same data set, names, these all are same, right? X and Y. Again, the seed is not required, not at all required. Yeah, seed is not required. So I've taken k fold. Again, this is just for the cross validation, k fold. Now I'm creating my sub model. This is what it is important. So estimators, I have taken the estimators. I'm taking the model one logistic regression. What does this estimator means and this bracket means? So suppose I have different models, right? I'm creating a blank for the Python, in Python language I'm talking about. Okay, so what I do is I want to tell my user, or I want to tell my user with the one who is running this code, that which is the best model. Okay, for that I have to take it at a place. So I am creating a blank this list. Okay, so this is what estimator is equals to, this blank list means. Now I'm taking all the methods into this blank list, and then I'll do the comparison. Okay, so model one was logistic regression, that I've called dot linear. So I'm appending means joining or putting. So I'm telling that append all the logistic model into estimators. I'll do again for the other two models. I'm calling again decision tree classifiers, and I am telling ki append all the decision tree like uh, classifiers data into estimators. This, so this is what estimators dot append me. And again for SVC, I'm labeling it as model level 3 and appending it, and I'm asking it to put all the estimators data into this blank list. Okay, done with this. My model 1, model 2, model 3, I have called, I have calculated everything on the same data set. Same data set, three different models. Now what I have to do, I have to see the mean of it. I see the result of it. How you can see the result of it? When we have the data in this estimator that we have put, right? Now I'm doing the voting classifier. So I'm asking to use the voting classifier and do the estimation. And I'm asking it to do the cross validation score, okay, in the terms of result, which is XY. And then now I'm calculating my mean, okay, and I'll have my result. Okay, so these all are not the error, these all are warning, which is telling the number of iterations or the okay, I don't know, I cannot see it. Let's do one thing, let's run it. Okay, some time. So I cannot see the accuracy. If you can see, let me know, because these are just the warning. So these are just telling you, okay, you need to increase the number of iteration or scale, some uh, inbuilt warnings sometimes they used to give. Okay, just a minute, it will take some time because it was not initialized. It will take time to run this program. So this is how my voting ensemble works. It basically take different models, take the like different models parameters into one platform, take the mean out of it, and give my result. I hope I get the result instead of just the warnings. Yeah, see, can you see now? 0.76. So it's similar again. It's same, almost similar results you are getting, 76.5. what we are getting for different algorithms. Okay, so this is what my ensemble learning is. I will deal with three types of ensemble methods: bagging, boosting, and voting. In bagging, we were having again three: decision tree, random forest, and extra trees. In boosting, we were having two models, which was adder boost and stochastic gradient, and then we have voting. Voting, we saw different kinds of models or different kinds of data in one particular different types of models for one particular data. And what it does is it calculate the different kinds of model for that particular data, take its values and calculate the mean out of it and give the results. Okay, so yeah, this is what ensemble methods in Python was. Okay, so do you guys have any questions? Please let me know. We still have 5 minutes, so we can have any discussions. Okay, I'll stop presenting first. Yes. Yeah. Yeah, please tell me. Gajanan, you have a question. You raise your hand. Please ask me. Mr. Gajanan, you have raised your hand. Do you have any question? Or if you're not able to speak, you can write it in chat box. How to select the models? Okay, what kind of models you're talking for voting? If you're asking how to select the models, it doesn't matter. Like, it depends on what kind of data set you're working on. Since I was working with a data set which requires a classification result, I took linear regression. I just wanted to take different kinds of model to show you an example, so I took linear regression, SVM, and decision tree. You could have taken anything. You could have taken KNN, you could have taken logistic regression, you could have taken any other model. So it depends on what kind of data set you're working. Again, I'm saying, so everything, the first thing for machine learning, start with the data set you are working on. First you have to analyze what kind of data set you have, and second thing, you have to see what is the result you are expecting, and then only you can start working on your model. Then only you can think what kind of model you can work with, and after choosing the model, what type of parameters, how to optimize it, everything you can see like this. So this is where it starts. I hope I'm clear. If you have any other doubt, please let me know. Okay. Okay, guys. Do you have any other suggestions for the next class, or I can take up on my own because we don't have much classes left, I guess. So I think after today we have three more classes left. So let me know if you have some particular topic you want me to deal with, or I could come up with a topic if you don't have any suggestions. Anything is fine with me. Any suggestions, guys, or any questions, anything? Thank you.
Ma'am, can I put in the discussion forum later? I haven't watched the sessions yet. So if
Uh,
I have,
like questions related to today's class?
no, ma'am, like to what you can do in the next class, what you can teach
Oh,
in the
great,
next.
great, great. Are you on that machine learning WhatsApp group?
Uh, Ma'am, I don't know. I don't
Okay,
think
okay,
so.
it's fine, it's fine. So this isn't. I mean, sorry, discussion group is fine with me. So just
Okay,
like sometimes this on the discussion group itself, it goes unnoticed. I would request you when you are mentioning it, keep my name in it so that I can be more focused. Okay, this is for me, something like that. Okay,
okay, ma'am. Yeah.
okay, okay. Then okay, guys. Then see you in the next class. Thank you so much for today's class.
Thank you, ma'am.